Who are you?
For me,
Yeah.
I'm a mole.
How come you sound really weird?
Well, I live underground. I have dirt in my mouth all the time.
Oh, well. You know what else is a mole?
What?
This. Check it out. Video 3-3, counting atoms and stuff. Okay. Now, there is something known as a mole. A mole is just simply a grouping of things. 6.0221367, and there's even more digits, times 10 to the 23rd things. Okay. So, 1 mole of eggs. A mole is basically just like a dozen. If you had a dozen eggs, you'd have 12. If you have 1 mole of eggs, you have 6.0221367 times 10 to the 23rd eggs. Okay. Now, this number, this is known as Avogadro's number. He was a scientist, came up with some ideas. He wasn't the one who actually determine this number, but it was named in his honor. Okay, and Avogadro's number is given the symbol n. So if you ever see n in a formula, that means insert this number. Okay, so that you don't have to write out this whole huge number, memorize this number to 4 sig figs. In other words, 6.002 times 10 to the 23rd. Remember that number. Okay. This chapter, we're using dimensional analysis. So if you had problems with it, make sure you get help or go back and review the dimensional analysis things from the last chapter. Okay. Now, 1 AMU. Remember this from the last lecture. 1 AMU was 1.660540 times 10 to the negative 24th grams. Okay, so suppose you had a sample of 1 mole of particles, and each particle was exactly 1 AMU. That means you had this many particles. Okay, how many AMUs would the sample weigh? Well, each one weighs 1 AMU, so it should weigh 6.0221367 times 10 to the 23rd AMUs. Okay. Now, how many grams would that sample weigh? Well, you know 1 mole is 6.022 times 10 to the 23rd. You have that many particles, and each one at 1 AMU is 1.660540 times 10 to the negative 24th grams. So what happens when you take Avogadro's number, multiply it times the mass of MU? Okay. Well, it turns out to come out to be exactly 1.0000 infinite number 0 grams. Okay. If you punch it in your calculator, it may not come out to be exactly that, but take more sig figs here, more sig figs here, it'll come out to be 1. Okay. So what's the significance of this? How much will 1 mole of carbon-12 atoms weigh in grams? Well, you know 1 carbon-12 atom is equal to 12 AMUs. Okay. Now, if you take 1 mole of carbon-12, that means I have 6.022 times 10 to the 23rd atoms. Okay. And each one weighs 12 AMUs. Now we just said, if you have 1 mole of things that weigh 1 AMU, they will weigh 1 gram. This weighs 12. So, turns out that it should weigh 12 grams exactly. Okay, now, make sure you understand this. 1 carbon-12 atom has a mass of 12 AMUs. If you have 1 mole of carbon-12, it will weigh 12 grams. Okay, change AMUs to grams if you have 1 mole of those things. Now, we come up with this concept, something called the molar mass. Now, anytime you see this term molar, it's going to come up a whole bunch of times. Molar basically means that you have 1 mole of the substance. So molar mass is the mass of 1 mole of the substance. Okay? The units are grams per mole. Okay? Now, make life easy on yourself. Remember this concept right here. The molar mass of a substance is simply its atomic mass. But instead of being in AMUs, the units are now in grams. Okay. Now, how do you figure out the molar mass of a compound? Simple. It's equal to the sum of the masses of all the elements, all the atomic masses of the elements in the compound. And if you have subscripts, multiply each element's atomic mass by the subscript. Okay, so a couple examples. Find the molar masses of these things: NaCl, CO2, and this compound here, calcium C2H3O2 in parentheses 2. Okay, so molar mass, simple. Okay, well, we need some molar masses. Sodium's molar mass, 22.99. Remember, these are all from the periodic table. Okay, now, once you take the molar mass, that means you have 1 mole of them. So all the units, 22.99 AMUs, now becomes 22.99 grams. Oxygen, 16.00, etc. Okay, so for sodium chloride, well, sodium, I have 1 mole of sodium, 1 mole of chlorine here. Sodium is 22.99, and chlorine, 35.45. All I have to do is add them up together, and I should come out with 58.44 grams. Okay. CO2, I have 1 mole of carbon. Carbon weighs 12.01 grams. Then I have to add it to oxygen, which is 16.00 grams, but the 2 means I have 2 moles. 1 mole weighs 16, so multiplied by 2, and this should give me, whoops, let's get rid of that, 44.01. Okay. When you multiply this by 2. Okay, now, this one here, Ca, 2 Cs, 3 H's, O2s, times 2. Okay, so in that one right there, that means I have 1 calcium. I also have 2 carbons times 2. That means I have 4 carbons there. Plus 3 H's times 2. I have 6 H's. Plus 2 oxygens times 2. I have 4 oxygens there. Okay, now, how much does all of this weigh? Well, calcium is 40.08. Carbon is 12.01. But I need to multiply it by 4. Hydrogen is 1.008 grams multiplied by 6. And oxygens, I have 4 of them, multiply their mass by 4. All that should give you 158.168 if you add all this up correctly. Okay, now we have an equality. If you have 1 mole of element X, its mass in grams is equal to its atomic mass. Okay, now, because we have an equality, and we know the equality here, remember, if you have 1 mole of any element, it doesn't matter what that element is. You have 6.022 times 10 to the 23rd atoms of them. Okay? These are equalities, which means we can now do dimensional analysis, which means I can make a conversion factor. I can say 1 mole of X over the atomic mass of X in units of grams. I can change moles into grams, okay, or grams into moles, or you can flip the top and the bottom. You can also make another equality with this one right here. We can say, we can put moles on the top, moles of X on the top, and 6.022 times 10 to the 23rd atoms of X. Or I can flip the top and the bottom also. Okay? These are equalities. You can change moles into grams, grams into moles, moles into atoms, atoms into moles. Okay? Never, ever, ever put this number, 6.022 times 10 to the 23rd, Avogadro's number, in front of grams when you're setting up an equality. Okay? The grams is always comes from the atomic mass, the one that you find on the periodic table. Okay? Now, a little bit more advanced, but not really. Okay? One molecule of C6H12O6, this is a simple sugar, like something like glucose, has 6 carbons, 12 hydrogens, 6 oxygen atoms in it. Okay, now, what if I had 1 mole of C6H12O6? How many moles, not how many carbon atoms, how many moles of carbon atoms do I have? Well, simple. 6 of those. How many moles of hydrogen atoms? 12. How many moles of oxygen atoms? 6. Okay, same as the coefficient, 6, 12, 6 when you're going from a molecule to atoms. When you go from moles to moles, it's the same. Okay, so we can set up a little equality here. You can take moles of a compound and break it up into moles of each element. Okay, now, how do you figure out what these numbers are here? Simple. Okay, remember this. Write it down if you have to. The number in front. Okay, times the subscript. Has to equal the number in front, or your coefficient, times the subscript. Okay. So 1 times A is equal to A times the subscript of 1. 1 times B is equal to B times subscript of 1. Okay. So 1 mole of Na2C2O4. How many moles of each element do we have? Okay. Number in front times the subscript. 1 mole of Na2C2O4 has 2 moles of Na. Number in front times the subscript equals number in front times the subscript. Okay. 2 moles of carbon, 1 times 2 is equal to 2 times 1. Now, moles of oxygen, 1 times 4 is equal to 4 times 1. Okay. So, we now have 1, 2, 3, 4 equalities that we have. Okay. And remember, equalities let you change anything from one side of the equality to units on the other side of the equality. Okay. Moles of X then. All our equalities, moles of X, can be changed into atoms of X. Moles of X can be changed into grams of X. Moles of X can be changed into moles of XAYB. Okay. So, this is a roadmap. Okay. This is going to help you in doing your problem solving. You know you can change moles into atoms and atoms into moles because you have an equality. You can change moles of X into grams of X and grams back into moles. The arrows go both ways. Okay, and we just saw we can change moles of X into moles of XAYB. Okay, how do I get from here to here? I need an equality. Okay, whoops, moles of XAYB can go to molecules of XAYB and also grams of XAYB. Okay, how do I go from here to here? Or from here to here, we need an equality. 1 mole of X, 6.0221367 times 10 to the 23rd atoms. Okay, 1 mole of X is equal to the atomic mass of X. Okay. Problem solving. Map out the problem first. Read your problem, figure out where you are on the map. Just like when you navigate and you want to go somewhere. You want to figure out where you want to end up at and where you're starting at. And what roads take you to how you get there. Is there a straight point or do you have to go through an intermediate stop? Okay, so an example. What's the mass of 3.60 moles of copper? The mass means I'm looking for grams of copper. Okay, get into the habit of writing out what the substance is. Okay, so where am I starting at? I want to end up at grams of copper. This is my starting quantity. Okay, so I'm starting there and I want to end up there. So it's a simple one-step direction. Okay. Now, This is your mapping process. Get into the habit of doing this until you get really, really good at it. Okay? I'm going to require that I see you mapping out the problem. This is your mapped out problem, where you start and where you end. Okay? And any other steps in between. Okay? And it's simple. Once you have this part written out, the rest of the problem is simple. This arrow just simply means multiply, okay, by your conversion factor. So 3.60 times moles of copper, you see the arrow times something over something. Okay, common dimensional analysis. Units you want go on the bottom, or units you're getting rid of go on the bottom. Units you want go on the top, and get in the habit of writing out what the substance is. Okay, now make the top equal to the bottom. 1 mole of copper weighs how many grams? Remember, anytime you see grams, you always look up the atomic mass. Okay, the one from the periodic table. Look it up on the periodic table, 63.546. Notice the units cancel out. You know you did it correctly, and you come out with 229 grams. Now the review. Which one of these samples will have more atoms? 1 mole of sodium atoms, 1 mole of lithium atoms, 1 mole of water molecules. They all have the same number of atoms, or it cannot be determined.